The internet is an abbreviation on interconnected network and can be thought of in the same way that streets, roads, and motorways connect people with shops, services, each other, and the pubs. People can send each other messages or purchase items by leaving their homes and travelling to shops, using shared common language and currency, and each property has its own unique address. In networking terms, we call these homes, shops, and services nodes. The languages they talk to each other in are protocols. The services they use could be email, phone apps like internet banking or online games, and unique addresses are applied by IP addresses. More on those later. So each node or property could deliver messages to each other or exchange money for goods or services, depending on who was initiating the interaction. But the most common example most people think of when thinking about the internet is visiting a web page. So to explain how this works, let's visit the pub. The internet consists of over 1 billion websites, although reports state that only about 200 million of these are actively used and maintained. We're going to struggle to replicate that level of scale in a pub, but to help with this analogy, we're going to imagine that this pub sells 100 different types of beer. With that amount of available drinks, the barman is going to need to learn the location of every beer tap, so he needs a system to locate them. He uses a directory where he can input the beer ordered and be told where to locate the beer tap. So for example, if someone orders a pint of ABC beer, it might be in position 3, as opposed to XYZ beer, which might be in position 72. Equating this to the internet, due to the size and dynamic nature of web pages, we use DNS or domain name system to locate resources, where each domain or organization maintains its own list of publicly accessible servers. DNS is a way to translate human-readable web addresses like www.abc.com to a system-readable IP address like 1.1.1.1, which is the actual location of the resource. Whenever you enter a web address in your browser, a series of DNS lookups occur to find out the remote IP address, and routing decisions will be made to find the quickest path there. Back to our beers. The barman has looked up the location and found his way to the beer tap. The process to open the tap is pretty simple, and very quickly the cool amber liquid fills the glass. The beer is made up of lots of individual ingredients that on their own aren't terribly tasty, like water, malt, yeast and hops. Luckily for us, the brewer has already mixed these ingredients, let them brew to build flavours and alcohol levels before packaging in a keg for delivery to the bar. This is similar to the process of building a web page. To request a website, your browser creates a Hypertext Transfer Protocol request, otherwise known as a HTTP GET request, and sends it to the server that it has identified as having the website files from a DNS lookup. A designer or DIY builder will have used ingredients like images, scripts, and cascading style sheets to create and style the website. The website will be saved in Hypertext Markup Language, or HTML, to be sent to whichever browser asks for it. If it's a secure website, then it will use HTTPS instead, and this ensures that the data is encrypted in transit using transport layer security. Rather than liquid form, these websites are delivered in a series of packets, the equivalent of delivering your beer teaspoon by teaspoon until a pint glass is full. Once the beer is settled, it is delivered to you. If you're still at the bar, that's a relatively simple process, but if you've taken a seat, then the bar staff are going to need a way to locate you. In the web world, your location, in the form of your IP address, is sent along with the GET request, so the server knows exactly where to deliver the HTML files to build the website. IP addresses are an important element of the internet, so let's explain a little bit more about how they work by imagining that you've now finished your beer and have moved on to cocktails. IP addresses consist of 4 numbers between 0 and 255 separated by a dot. Here you can see an example of one you may have on a home network, and this is how your internet-connected device sees that same number. Each of the 4 sets of numbers, called octets, are defined by 8 binary digits. A binary digit consists of one of 2 options, a 0 or a 1. This is known as base 2 numbering. The equivalent everyone will be used to is base 10, where each digit can be one of 10 variations, 0 to 9. Using these 32 binary digits, or bits, broken into 4 octets, we can create unique addresses that allow network devices to communicate all over the world. To demonstrate this, our mixologist has 8 spirits lined up. You either have a shot of each in the cocktail, which will designate with a 1, or you don't, which will give a 0. Ignore the 1s and 0s for now because I'm about to throw a lot of numbers at you, so let's remove that potential confusion from the equation. The spirits range in ascending strength from right to left. The spirit on the right has an alcohol score of 1, the next scores 2, the next is 4, then 8, 16, 32, 64 and 128. If you have all of the shots, the strength of your cocktail is 255. If you don't have any, the strength is 0. and every number in between can be shown in the same binary format. If you only have the first spirit, it's a strength of 1. A strength of 2 is achieved by only having the second spirit. A cocktail strength of 10 is made up by mixing spirits 5 and 7. A cocktail strength of 100 is made up of spirits 2, 3, and 6. And a cocktail strength of 200 uses 1, 2, and 5, and all of the numbers in between. If we just use one octet, we can define 256 different numbers through only 8 binary digits. By using 4 octets and just 32 binary digits, we can define over 4 billion different numbers. This is the total pool of IPv4 addresses. And with 8 billion people in the world, you can see why we're moving to a newer version of IP addressing called IPv6. IPv6 sits with other elements of IP addresses like subnet masks and public versus private IPs that add extra layers of complexity, and you'll probably need a stiff drink to get through all of those, so we'll save them for another video. Binary is not just used for IP addressing though, it is the language network communicating. Data packets sent over Wi-Fi or Ethernet cabled networks also send their data in streams of ones and zeros. To give a basic example of how that might work, let's assign the value of 1 to the colour orange and 0 to the colour white. While the data is being transmitted, it will look like this. When the computer compiles it, data in the header will give the type of file, in this case image, and the dimensions of the image, so the computer can construct it and the ones and zeros will end up looking like this. Now imagine that instead of single binary digits to show a colour, we use 8 bits. Now each pixel can be one of 256 colours. If we use 16 bits to represent a pixel, we now have 65,536 potential colours. The size of the file will go up to store all of this data, but our pictures are much more enriched. Now the last thing we need to worry about is the beer reaching you without any spillages. Our bar has created a full and spill-proof delivery mechanism. In networks, this transmission of HTTP information happens over TCP or Transmission Control Protocol. This ensures that the whole web page reaches you intact as designed, and if any of it is lost, it has mechanisms built in to request missing packets, leaving you to a full, delicious pint of beer. Cheers!